This is Honors Geometry, Section 11.3, Equations of a Circle. Standard equation of a circle. In general, an equation for a circle with center, HK, and a radius of R units is given by the equation. It's the difference of x and h, quantity squared, plus the difference of y and k, quantity squared, equals the radius squared. So to be clear, again, we're saying that the center has coordinates hk and that the radius is going to be the square root of r squared, which would be r. Notice this formula, this general equation of a circle, has minuses in it, subtractions. That's x minus some number. That number could be positive or negative. Let's see if we can look at an example and make some sense of this. Determine the coordinates of the center and the measure of the radius of each circle whose equation is given. Well, according to the standard equation of a circle, this is h and this is k. Keep in mind this has to be subtract, which it is. So our center is the ordered pair 7, 4. The radius, which is going to be the square root of 6 squared, square root of 6 squared is 6, so the radius is just 6. Let's look at number 2. The equation of a circle is supposed to be x minus a number, but this says x plus 5. X minus a negative 5 is equivalent to x plus 5. Y minus a negative 11 is equivalent to y plus 11, which makes the center for this the ordered pair negative 5, negative 11. Remember, the formula is x minus a number, y minus a number. The radius is the square root of 8 squared, which is 8. Number 3. This is supposed to be x minus a number. It is. It's x minus a positive 12. You don't have to write the positive, but you can if you want. And then we're adding to that y minus a number. Right now it says plus 17. That would be equivalent to minus a negative 17. And 100 is the same as 10 squared. So the center is 12, negative 17. And the radius is the square root of 100, which is 10. Number 4. It's supposed to be x minus a number. X minus a negative 21 is the same as x plus 21. We've got y minus a positive 41 squared. And then we have equal to 49. 49 is the same as 7 squared. So our center is negative 21, 41, and the radius is 7. This next one's a little tricky. Can get you. If we rewrite this one, it would be x minus 2 quantity squared plus y minus 1 quantity squared. Now this says the square root of 81. So what's on the right side? What's the square root of 81? Well, that's 9. 9 is the same as 3 squared. So the center for this is 2, 1, and the radius is the square root of 3 squared, which is 3. Number 6. Now we're getting real cray-cray. We could write this as x minus a negative 1 squared plus y minus a negative square root of 2 squared equals 98. Now 98 is not a perfect square. I don't know what its square root is. The center for this is negative 1, negative square root of 2, and the radius is the square root of the constant, it's the square root of 98. 98 is the square root of 49 times 2, which is 7 square roots of 2. The radius is 7 square roots of 2. The coordinates of the center and the measure of the radius of a circle are given. Write an equation of the circle. Well, it's supposed to be x minus the x value of the center plus y minus the y value of the center squared equals the radius squared. So the coordinates are 4, 9, and the radius is 8. That makes this the difference of x and 4 squared plus the difference of y and 9 squared equals 64. Yay! Number 8. This is supposed to be the general equation of a circle, x minus a number squared plus y minus a number squared equals the radius squared. So the x value of the center is -5, the y value is -8, and the radius is 11. Simplifying this, it's x plus 5 quantity squared plus y plus 8 quantity squared equals 121. Number 9. It'd be x minus a -3 squared plus y minus 6 squared equals the square root of 2 squared. Square root of 2 squared is 4. Y minus 6 quantity squared was fine how it was. X minus a -3 is the same as x plus 3. Last example of this type. We have x minus a number, quantity squared, plus y minus a number, quantity squared, equals the radius squared. So this is y minus a -19 and x minus 14. It's going to be x minus 14 quantity squared plus y plus 19 squared equals 10. We got two more problems here. Number 11, it says graph each equation. So to graph the equation, we would want to know the location of the center and the radius. If you like, rewrite this as x minus a -1 quantity squared plus y minus 2 quantity squared. And this over here is going to be the same as 3 squared. So the center is -1, 2. So from the origin, you go left 1 and you go up 2. Puts us right here. And the radius is the square root of 9. Or you could say it's the square root of 3 squared. Either way, it's going to be 3. Now I can do this in a magical way. You can't. So my magical way is I can just draw this circle and then I can extend it up 3 units to the left, right, up and down. And I could say the radius is 3 and the center is at -1, 2. You're going to have a harder time doing that. So what you might want to do is count to the right 3 of your center, count up 3 of your center, count left 3 of your center, and count down 3 from your center. That one is down a little far. And then just try your best to connect them, making a circle. So that concludes that example. Let's do another. Let me color this in just to be nice. This next one, this is not in the format that we're used to at all. First of all, this constant is supposed to be on the right side. So let's add 25 to both sides. Second thing, it's a little bit weird. This just says x squared. Isn't it supposed to be x minus a number? Well, x squared is the same as x minus 0. And then x plus 6 is the same as y minus a -6. So the center for this is 0, -6, and the radius is the square root of 25. I'm in trouble with my 5s today, which is 5. So we go from the origin down 6, 1, 2, 3, 4, 5, 6. Then you count to the right, it says the radius is 5, 1, 2, 3, 4, 5. Count to the left 5, 1, 2, 3, 4, 5. Count up 5, 1, 2, 3, 4, 5. Down 5, 1, 2, 3, 4, 5. Center was at 0, -6. Radius is 6. Try your best to make a circle that goes around there. Easy for me because I have a magical iPad as opposed to a regular iPad. Now notice you can't count 5 diagonally because the diagonal is longer than a segment. So like if you go, well, 1, 2, 3, 4, 5, it doesn't make any sense. So when you're counting these spaces, count vertically and horizontally. This, let me redo that. This length is the same all the way around. That's what makes a circle a circle. This is a collection of all the points that are exactly 5 units away from the center in this two-dimensional plane. That concludes the notes. Please do the homework for section 11.3. Let me just color this once again for your viewing pleasure. It's beautiful.